Hello class, congratulations on completing the assignment 5, the Geoprocessing challenge. I know it was a difficult assignment to do, and you all persevered, so bravo, congratulations. So let's just go ahead and do a very quick review of the geoprocessing tools that we have under our belt so far. So this is just an outline of some of the tools that we'll run through today. And let's begin with attribute extraction. Attribute extraction, as you know, is when you for instance, if you have the census tracts of an entire state, you can look at the attribute table of those census tracts, identify your county code, and easily through a select by attribute, filter out or highlight all of the census tracts that are within a particular county you want to work with. So this was Illinois, and we wanted all the census tracts that are within Cook County. And so using the select by attribute, we highlighted all of those, and by right-clicking and exporting that into a geodatabase that you created a new shapefile that represents just the just the Cook County census tracts. Attribute extraction is something that is a basic geoprocessing function that you should be very well versed in. The other tool that we have under our belt is feature location extraction. This is a very powerful function of GIS that allows us to identify spatial relationship between layers and find features that are within another layer or within a distance of another layer. So for instance, if you have the Cook County census tracts, but what you want is the census tracts that are within the city of Chicago only, but there's nothing in the attribute table that tells you which one of these census tracts are only in the city of Chicago. You only have codes for which census tracts are within the Cook County. So we don't have an attribute for Chicago. So what do? Another option would be to use a municipality layer. So for instance, most municipalities have a city limits layer. So if you wanted to find out, if you wanted a polygon that represented the city limits, so the Philadelphia city limits, you could easily find that from the local municipality's GIS website. So in this case, what we have is this highlighted right now is the city limits layer. It's kind of hard to tell from this image, but what we have is the municipalities layer for Cook County, I believe. I'm not sure. So for instance, what we have here is the municipalities layer, a layer that represents municipalities, and we've highlighted Chicago and created a shapefile that represents just Chicago, and that is by selecting by using just a normal selection tool or selecting by attribute and creating that shapefile. Using that shapefile, we then select by location all of the census tracts that fall within, that have their centroid point within the Chicago city limits. So as you can see here, the select by location tool that was used was all the target layers. So target layer is what will be selected. So that would be the Cook County census tracts that fall within the source layer. So that is the Cook County municipality, or actually it is the Chicago city limits. And we choose target layers features that have their centroid in the source layer feature. This is going to get you a very exact match with your selection of what falls within the city limit of Chicago. And the result is all of the census tracts that are within the city limits of Chicago, and that is your new area of interest. Hint on your next assignment is that you may need to have census tracts for a particular neighborhood or boundary within Philadelphia. Another powerful tool of GIS is location proximities. So, for instance, if health officials in Minneapolis have identified that there is a source of contamination in their water bodies, but where do they begin their search to find liability? Perhaps what they would do is try to find where there are polluting companies within a certain distance. So, in this case, they decided a half-mile distance of a local water body is too close for a polluting company, and so a select by location tool can easily find that information. So the target layer is the polluting companies, that's what's going to be selected, and the source layer is our water bodies, our lakes and rivers. And so the selection method in this case is target layer features that are within a distance of the source layer, and the distance radius that we are applying is a half-mile radius. So any polluting company here, so the red dots are the polluting company, anything that is within a half-mile radius of a water body is going to become selected. And there is how you can easily identify the potential polluting companies in Minneapolis. We can use the select by location features for polygons intersecting lines. So for instance, if you have a transportation planner that wants to know what neighborhoods are affected by a construction project on a major highway, you can use the create that layer, so select by attribute and create the layer that represents that particular highway, and use the select by location to find which neighborhoods intersect, meaning touch, this highway. And so you've identified 6 neighborhoods that would be affected by major construction on this highway. So let's look at, that's what I consider geoprocessing function, right? These are some of the functions that we have, unique capabilities that we have in GIS that we don't have in other two-dimensional tools such as AutoCAD. But the real power in GIS really comes from not just this, but the geoprocessing tools that are available to you. And that's because these tools allow us to manipulate data. It allows us to take multiple data sets and produce output data sets of information. Some of the common tools that you are already familiar with is the analysis toolbox, which is the extract. Some of the common ones in that toolbox is extract or clip, overlay, intersect, and union. The data management toolbox have the generalization, dissolve tools that you've used, and the general toolbox have the append and the merge. And do you remember what the difference is between an append and a merge? Well, by next class I'm hoping that you know this. So these tools can be found in the geoprocessing toolbar, as you already know. They are also, you can find them in the ARC toolbox, and you can access the ARC toolbox by just clicking the ARC toolbox here. And these are all the system-built tools that exist in the ARC toolbox. A lot of really fascinating and interesting tools that you could work with. So I encourage you to explore other tools within this toolbox outside of what we'll be using in this class. The feature that I love about ArcGIS is that if you're not sure exactly how a tool works and you kind of want to learn a little bit of learn some information about it, the tool always opens with the tool help feature available. So it has an explanation of how the feature works overall. So this explains exactly what the clip tool will do. And if you click somewhere in the actual tool, the help will adjust to what's displayed here, will adjust to show you what that particular section of the tool is doing. So as you're exploring other tools and new tools that we haven't used yet, this could be a very helpful function. I'm a big fan of the search window. I usually know what tool I'm looking for, or I have an idea or a partial name of that tool, so I really like using the search window to find tools, and that's also a great feature here of the ArcMap interface. So in your toolbar, the search, you can easily just go to search by clicking the search icon. So through the search, you can, underneath the actual tool itself, you can click the under the text, the blue text, and that will bring up the tool help, a window that really represents the tool help in a way. It's the item description of the tool, and this is going to give you a very thorough explanation of how to use the tool, what the tool is for, and if you're a coder, if you really get into ArcGIS and you want to start designing your own scripts to create certain tools, it gives you examples of what the standalone Python script is. So in addition to knowing how to access the various tools, another very important and good website that you should all be very familiar with is resources.arcgis.com. So that's resources.arcgis.com. And just scroll down to the ArcMap. So when you get to the home page, scroll down to the ArcMap window or tab. That will take you to this page where you can download a trial, look at various different existing web maps and different ways to perform analysis. So these tabs are tabs that you want to be familiar with. So for instance, if you click on the map tab, this has a bunch of different instructions on how to work with things. So how to change symbols, how to create layers, how to create graphs, reports, information about map projections. A lot of information is available to you through the resources.arcgis.com ArcMap page. So please become very familiar with this, because as you get into your projects, you will need to perhaps do some research on your own if you haven't already. I think some of you actually really were vigorous with your research on how to tackle the geoprocessing assignment, and so this website will be very helpful for future assignments as well. So you extracted features by using a tool called Clip, or you can extract features by selecting by location. So for instance, this is, I believe this is downtown Pittsburgh. And so what we did here, what we're looking at here is two maps, the two versions of the streets within Pittsburgh. And it depends on what you're trying to do. So for instance, you can create streets within downtown Pittsburgh by just simply using the clip clip tool to create that, and it'll, if aesthetic is what you're going for, you just want the map to look pretty, then fine, that works out just fine. But if what you're trying to do is create a some sort of, perhaps you're doing geocoding, or perhaps these are census boundaries that are within a certain area, you want to be careful with clipping. You, for instance, do not ever want to clip any type of census boundary, because if you are looking at census data within a boundary, and say for instance your area of interest at your study only covers 25% of that census tract, and say that's that bottom. So for instance, if this was if this area was a census tract, and your entire population is really here, but your area of interest is over here, and you clip that census tract, well, all of the information that was in the attribute table of that census tract will come in, and you'll be reporting inaccurate data, because your census tract, the partial census tract that you clipped, will have information of a population that's really not there. It's over here. So just be very mindful of when you're creating new layers based on a clip, or based on select by location. So for instance, if you're geocoding, and we're not using the book, so we're not going to get into a chapter on geocoding, but if you were geocoding and say an address fell on this street segment here that is just outside your area of interest, that address wouldn't geocode because you clipped it out. So it's important, and that particular street segment would have not been clipped out if you use the select by location. So I hope I'm getting my point across, that when you're creating a layer based on if that layer is within the boundary, just be very mindful of what it is that you're clipping or what it is that you're creating. Clipping may not be the tool that you want to use. You've also been working with the Dissolve tool, which combines polygons to create new larger polygons. So it uses a common field value to remove interior lines within each polygon, forming a new polygon. And it also aggregates sums of data while dissolving. So an example of that would be if you had for instance, if you had all of the states within the country, and you know that those states are divided into a sub-region of the country. And so you could use the Dissolve tool to not only dissolve those polygons into larger polygons representing that sub-region, you could also conduct analysis by getting the tool to also report back to you what is the sum of the population within the polygons, the state polygons that are being dissolved into a larger polygon. What is that total sum? So you're going to know the population. Right now you have a population by state, and the result of this tool will give you population by subregion. So you would find in the data management toolbox under a generalization of the Dissolve tool, or you can just search Dissolve, and the input would be the United States. The output feature class, you would name something like US regions. That makes sense, right? So these are regions within the United States. And the Dissolve field that you want to use is sub-region. So basically every state that has a sub-region field, that's those states that fall within a certain sub-region will dissolve into one large polygon. And if you have a bunch of demographic information that you want aggregated, you can do that here. So for instance, population in 2007, if you wanted a sum of that, the new attribute table will give you that. And you can do that with multiple attributes. Important to know, you can do that with multiple attributes. So if you also had income, you can ask for, so if you had income as one of the attributes of the states, like median income in that state, what statistic type do you think you would choose there? Probably average, right? You wouldn't want to sum up the entire, that would be like millions and millions and billions of dollars, because it would be adding up all of the income. But with people, you do want to do that because you want to get a total population. So you run this tool in the resulting map. So you run this tool and the resulting map is going to be this. It's all the states that fall within a region, sub-region now is just one larger polygon, and you get information about each one, population information about each of those regions because you ran that statistic portion of the tool. So another tool that other tools that we've worked with is the append tool, as well as the union tool, and the merge tool. Let's begin with the append. The append tool appends one or more data sets into an existing data set. Right, so what that means is the features must be the same type, so lines and lines can be appended together, points and points, polygons and polygons, and you're not creating a new feature, you are adding an existing feature to another existing feature. So this is the fundamental difference between these tools. So become familiar with the difference And an example of how the append tool would work is that, for instance, if a sometimes counties keep their spatial data separate from one another, usually actually. So if you're working in a large project where you need to have a street layer for 2 counties, an append tool would be a great way of doing that. So you'd be able to just, using the append tool, you would add the Cook County street layer to the DuPage County street layer. So that DuPage County street layer will now have all of the Cook County attributes. The merge tool combines multiple input data sets of the same data type into a single new output data set. So appends is one or more into an existing. Merge combines multiple data sets into a new output. So in this example, the Illinois campaign manager needs a single voting district map but wants to preserve the original layers. So using the merge tool, you just add the 3 voting districts, and the resultant layer is a new voting districts layer. So these are polygons that represent voting districts for multiple counties, but then once we ran the merge tool, it is now one entire voting district layer. So the union tool overlays 2 polygon layers, and the resulting output layer has combined attribute data of the 2 inputs. So it contains all the polygons from the inputs, whether or not they overlap. So this could help to create a better understanding of 2 polygon layers. So for example, if we have in downtown, or a neighborhood layer in downtown Pittsburgh, so these are all of our neighborhoods, and we also have a zip code layer. And remember, these are layers with lots of information, information that came from different sources. So whoever created the zip code layer added attributes that they were able to find based on zip code, and we also have a layer that is the neighborhoods with attributes based on those neighborhoods. So how can we get all of those attributes together? A union is a great way of doing that. So if you run a union tool on these 2 layers and have the join attributes all, the resulting layer could be something that better describes the characteristics of a neighborhood. So for instance, which part of a neighborhood is either within this particular zip code or that particular zip code. Right? So remember, looking at this particular section, this is what it looks like. This right here, this is what it looks like before the union. And these are the attributes that came with each individual layer. And now that section has been sliced to give you what information about that part of the central business district that fell within this particular zip code, the 1522. So the resulting layer now has information about that 1522 zip code. The intersect tool is also a great tool. It's in a way kind of like the opposite of the union, because what it does is it gives you just what is at the intersection of 2 layers, or 2 or more layers. And what I like about this tool is that you could have multiple different types of geometry. So it can be, so as you can see in a description here, it can be point, line, or polygon. So an example of the application of an intersection would be, so if a city manager needs to know what buildings intersect flood zones, and want the flood data attached to each intersecting building, they would simply, so the blue area represents flood zone, right? So within, if you see here within the curb edges, that's the actual water body. That's the river, or the river in downtown Pittsburgh. And then beyond the line, the line here, that is where there is actual development. That's where these buildings are. So these buildings are within the flood area, flood hazard area. running a intersect tool where you intersect the feature inputs are the buildings and the FEMA flood line, and the joint attributes are all. The resulting layer is going to give you just the sections of the buildings that are within the flood zones and information about that building and the flood zone. So you get information from the flood zone layer and information from the building into one new layer that just represents the section of that building that is at risk. And finally, there is Model Builder, which is a very cool thing to be able to do, because with Model Builder you can actually create your own custom tools. And that's where attribute field types, data types, so whether a field is a string or a float or a double, that's where having the knowledge of those different types of field types and what they mean for a tool is important, because you can easily create new tools, but sometimes a tool requires a field to be a float, and so it's important to kind of know what you're doing. I strongly recommend that you take the next level of GIS. So we're in Intro to GIS now, and Advanced GIS is the next class. For some of you it's a requirement, for some of you it's not. The professor of that class is Shay O'Neill. He's my colleague at work, and he's a genius when it comes to Model Builder. I strongly recommend that you take that class. But you did get an introduction to it here in this course, and some of you really did an outstanding job in figuring out how to get through the assignment. So let's just talk a little bit about Model Builder and the assignment that you worked on. So again, Model Builder it's a way to automate and string various tools together into one tool, and there's some really interesting types of analysis that you can do with multiple data sets at multiple different geographies with just one very robust Model Builder tool. Steps that you went through with your exercise was to join a crosswalk table, which basically is just a fancy way of saying a table that has neighborhoods and the tracks that each neighborhood fall within, and tracks, and you dissolve those to create neighborhoods using the dissolve column in the crosswalk, and you remove the join so that the model can be rerun if necessary. And you run the model for this workflow with just one click of a button. So if you become very familiar with Model Builder and you start using Model Builder in your future GIS work, you'll see how much time it can save you if you're going to run a bunch of tools to really get. Some of you had questions as to why you would even add a parameter to a model. And on the resources page of ArcGIS, there's a lot of information about model parameters and what they're used for. But basically, the two primary reasons to make a model variable a parameter is so that the output variables that are set as model parameters are added to the map when the model is run inside Model Builder. So that's one reason. And the other reason is variables that are set as model parameters show as a tool parameter when the model is run as a geoprocessing tool. This allows you to specify different data or values for your model to process than what was specified when the model was created. Hopefully that answers your questions on that. So that concludes a review of the geoprocessing tools. I strongly recommend that you are familiar with all of these tools. When we see each other again, you will be expected to answer some questions that could only be answered by running specific types of tools that we went over today. So before I go over your challenge, your next challenge, let's just go over some of the homework assignments that you've turned in. So the first part of the assignment, which in the packet is referred to as 6.1, 6-1, was to create a map, create a study area of Jefferson and Denver, Colorado. And so a good way to turn that in would have been to have of course, your name and date. Please always remember to put your name and date. I appreciate that everyone provided answer, or mostly everyone provided the correct answers to the questions, but it would be nice to just in the future to answer in this type of format where you have the questions above and then a very well designed map below. So this is kind of like an example of the map that I was looking for. Here we go. So this is an example of the resulting map that you should have had. For the most part, everyone did really well with this. Your legends to your map. It's important that you are adjusting in your table of contents how your numbers are looking. So for instance, with cities, I saw that many of your legends did not have commas, and it's just a pet peeve of mine. So just for future reference, please make sure that you fix that, and the way that you fix that is you just go to the properties of that layer, so right click properties, and you go to the symbology, and here is, if you just left click under labels, you can format your labels, and you can make sure that you're showing your 1,000 separators. That will add the commas to your numbers, and that just a little pet peeve of mine. So just make sure in your future maps that you're adding that. So that was, for the most part, everyone did a good job with this map. So just that one little minor issue. Another thing I want to mention is that some of you were having issues with getting an error message when you exported, when you were trying to export the layer. You were doing everything correctly, but you just got an error message. And after everyone left last time we met, I was working with a couple of you and we identified that problem. And so if you're still having that problem, what happened was when you download the data from Blackboard, sometimes what it does is it creates it as a read-only. So if you just in a Windows Explorer window, right click on that geodatabase folder, and if you see this checked off, read only, uncheck it and click OK, and apply it to all subfolders, and that should fix your error problem. It just basically, for some reason, it's saving it as a read-only file. So try that if you get any errors with exporting. However, that was happening when you were with people who were exporting their data to the source geodatabase. So the database that I provided to you that had the source data, when actually you were supposed to have been creating your own geodatabase. So, you know, you shouldn't have had that problem because you should have been creating your own geodatabase, but just so you know, that's what was causing that error message. So the part 2 of assignment 5, which the packet referred to as 6-2, was a exercise where you dissolved property parcels to create a zoning map of a particular area. Everyone did a really good job with that as well. So the resulting map should have looked something like this. And where you're calling out your proposed commercial parcels, these particular parcels. And by the way, zoning colors are what they are. So in the future, if you ever create a zoning map, make sure you look up what zoning colors are supposed to be. Residential is always yellow, commercial is always like a red or like a light red or a pinkish color. Industrials are usually like some kind of purplish kind of color. So just make sure that you are familiar with what the zoning color should be in your area if you're ever creating a zoning map. That's important to know if you're working with zoning or land use data. Another little pet peeve that I saw a lot in your assignments is not providing me with dollar signs and commas in your tables. So although most of the answers that you provided for the tax values by zone was correct, I really want to be, you know, I want clear numbers to see, so I want dollar signs and I want commas. And again, the way that you do that is if you open the attribute table of whatever feature that you are getting this data for, you can set that in the attribute table. So if I right click the column heading, then I get information about that field. So the name, I can give it an alias of whatever I want it to be. If, you know, if this doesn't make sense to me, I can give it a different alias. I know what type. If you click on this little numeric box here, it takes us to that same box that we can click on through the symbology. And here is where you can change it to currency or whatever it is. So that's how you would make sure that you get your commas and your dollar signs and your numbers. So in the future, make sure that you're reporting your numbers accurately as dollar values. But overall, good job everyone on this. Some of you made a comment about, I'm not sure exactly why this was happening, but for some reason your scale box was grayed out. So you weren't able to change your scales, and you weren't able to, I suppose you may have had some trouble with adding a scale bar. I really have no idea why that was happening. If it's still happening, let's look at it together next class. It could be some kind of fluke, or it could be something we might have accidentally turned off, or an issue with map units. I'm not sure, but I have to actually get into your MXD to find out what's happening. And finally, the third part of the assignment 5, some of you struggled with, but most of you were able to get it done. And if you have specific questions, let me know. I haven't received any specific questions as of yet, but your model should have looked something like this. So this is the entire model, and it was kind of, it was kind of provided for you in the packet. However, it was still a little bit of a challenge to actually get the fishnet to process. So, but I think for all of you who did submit this, I'd say 99% of you submitted the correct output. So this is the result. This is what your map should look like with all of the layers turned on. If you have specific questions about this, please let me know. And now I'd like to get started on the challenge for next class. So for next class, I'd like you to have a project geodatabase established with some demographic and other layers already set up in your geodatabase. In the past, I've been providing you with the data that you need for exercises, but now I'd like you to begin to start actually downloading your own data. So let's talk a little bit about how to do that. Data is always going to come to you. Usually it'll come in a compressed folder format, so I strongly recommend that before actually you start downloading the data, in your GIS folder, we're going to create a new folder, and that's going to be your project, your final project folder. We will talk a little bit more specifically about what that final project is, but if you remember from the course proposal, it's either going to be something that I assign to you, or you can create your own project. Either way, the limits of your project will have to be Philadelphia. So our final project, inside that folder, I'm going to create a new folder, and we're going to call that the downloaded data folder. So all the data that we download from our online sources will go in here in compressed files, and we will transfer them into our project geodatabase. So let's set up that project geodatabase. In the final project, right-click it and create new file geodatabase. And we're just going to call it Philadelphia. We're going to make this our default geodatabase by right-clicking that geodatabase, and we're going to go ahead and save our map. So now we have our MXD, our geodatabase, and our folder where we're going to put our downloaded data. In Blackboard, there is going to be a document that will be available to you. It's called the Geospatial Data Sources, and this is a list of websites that you can go to get spatial data. Most of your spatial data will come from PASDA, This is the Pennsylvania Spatial Data Clearinghouse. It is not the source, the original source of the data, but they do a really good job of going to all the different sources, whether that's the water department or Parks and Recs or whatever department of Philadelphia that handles or that produces spatial data. They have all of that, most of that data in their clearinghouse, so basic base map layers will come from there. Other really popular data organizations are OpenPhilly, Azavia, and data.geocom. Open Data Philly is just pretty much any GIS user is going to be able to provide data. So, just be careful when you're getting data from these types of organizations. Make sure that you're verifying. Census data. Be careful when you're adding census data to your maps. If it's the first layer that goes into your map, it'll set the projection. And usually, if you're at a small scale, such as 1 county scale, you want to be within 1 state plane usually. And a census layer does not project other layers correctly. So just be careful with working with that. But just make sure you ask me if you have questions about projections. But to get census boundary shapefile, so that is your census tracts, or block groups, that is one particular website. It's the census.gov Tigerline. But tables actually come from a different place. So you get the boundaries from one location of the census, you go somewhere else to get the tables. So if you have census tract layers and you want to add population, then the population is an attribute table that you would find at the Fact Finder website. Other useful sources for spatial data will be available on this document. So go ahead and some instructions on downloading data from this document. So go ahead and take a look at this when you have a chance. So let's take a look at an example of data that we would download from POSDA. So these are like base map type of layers. If you just click POSDA on your Google search, the very first option that comes up is this Pennsylvania Spatial Data Clearinghouse website. That's where you want to go. And the tab you want to use is Download Data. You can use keywords. They make it very easy for you to download data, or you can look at all the data that's available for the particular county that you're working with. So here is all of the spatial data that is available for Philadelphia County. So what you have here is the actual title of the layer, the originator, and the year that it was produced. So this is very important information to know about your data. If you want to limit your search to just the city of Philadelphia, you can do it that way. So let's go ahead and download the Philadelphia city limits. If you click on, as you can see here, it was last updated in 2016. It's a pretty good data set. So click on that, and here it will take you to the metadata summary. Metadata is basically just information about the data that you're downloading. You can preview the data, but what we want to do in this case is we want to do a FTP download, a file transfer protocol download. When you click on that, it's going to ask you where do you want to save this compressed folder, and so you pick the folder that you created for your downloaded data. Once that file is downloaded, go to the downloaded data, right click it, extract all, and it'll create a copy of that uncompressed version. I'm sure you guys are all familiar with this process as you've had to do it 100 times already. If you don't see it automatically pop up in your final project's downloaded data, just right click downloaded data and hit refresh, and it should show up. And there you have it. There is your spatial data downloaded from Pazda. I noticed that when we went to the city limits, I noticed that now Pazda also has census. So remember, census tracts change every, census boundaries change every 10 years. So I want you to also although this is a demographic layer, this isn't really from this is not correct. This is from the U.S. Census. It's not from PASDA. But anyway, download the census tract layer, and then we're going to go to the Fact Finder website to get information. Okay, so we downloaded the census tract layer and we added to our map, and if you open the attribute, you'll see that what comes with the census tract layer is just some very basic information about the state, county, tract, and basically the geography codes that pertains to each one of these census tracts. And you also get information about how much of that census tract is land area and how much of it is water area. But what we don't have is the demographic information that we might want to know about the population living within these census tracts. So the website that you go to for that is the Fact Finder website. So here, let me slow down for a second. If you go to google.com and just type in Fact Finder, the very first option that comes up is Fact Finder from American Census. You want to go to the advanced search and show me all. So this is where you can download a lot of demographic data about a geography. The way that you begin by downloading demographic data is to first select the geography you're working with. So are you gathering demographic data at a county-wide level, meaning for the entire county you just want one record representing the total of something within that? Or in our case, we have census tracts, so we are getting data at a census tract layer. So to backtrack, what you do is you go to Geography tab, you pick a name for your geography, and in our case is we have census tracts, right? Our boundary shapefiles are census tract shapefiles. So we're going to click on census tracts, and then they ask you, well, where do you want census tract information? Is it within a state? And yes, so it's within Pennsylvania. So we just find Pennsylvania down here. And Pennsylvania is a huge state with many counties, so let's also make sure that we select Philadelphia, so our tables that we download will only have Philadelphia data on it. So select Philadelphia. Okay, so here are our filters, our geography filters. It's census tract is a type of boundary shapefile that we're working with, and the location is within Philadelphia County, that's within Philadelphia State. So we are good to go there. So now we have an option to pick a particular census tract or all census or information about a particular census tract or information about all the census tracts. So let's choose the first option, which is all census tracts within Philadelphia. So now we're ready to add this filter to our search. So we click Add, and we can close this window. So now that we have our geography chosen, we can start picking topics. I will provide you with a list of topics that I want you to add to your demographic shapefiles, but let's begin with a few basic ones. So with people, there's always a basic count, right? That's the total population. So you just add total population, you click OK, and you're going to have total population for 2010, and that's the SF1 data is the actual census count, and you're going to have also other options for estimates. So every year since 2010, the census does these estimates, but they're not as accurate as your 2010 full count, where they actually count every single person. In, like, for instance, 2014, they will do a count on a sample population. So that's the difference between an ACS, a 2014 American Community Survey 5-year estimate, and a SF1 total population, which is 100% data, 100% of the population data. So I want you to go ahead and get information about both. We want to see where it was at the last count and what the projections are for 2014. So checking those two, click download and wait for your file to download. It's always going to come in as the AFF_download. I strongly recommend that you rename it so that you don't get confused. AFF is American Fact Finder, and that if you download all your data that way, it'll be very confusing very fast. So name it what it is. It's total population at a census tract level and you got it for 2010 and you got it for 2014. Now you know exactly what's in this file, and because it's in your final project, which is Philadelphia, we know it's Philadelphia, you know the geography as well. Hit save. So basically this is attributes, so you extract it all, and what you'll find when you open the folder is that this is Excel tables. Excuse me, Excel tables of data. So you'll get one Excel table, which is an attribute table in GIS is an Excel table. It's a spreadsheet. One of the tables for each is a metadata table, and the other is the actual data itself. If you open the metadata table, what you'll see is that this is information about the attribute table you just downloaded. So it's telling you that you have a total of 5 columns in your attribute table, and the first 3 columns pertain to geography. So this is probably your join field, right? Your geography identification. And then the other 2 is actual data. So for instance, this is the ACS table, the ACS 2014 table, American Census Survey. So the first field estimate is a estimated total population for each census tract based on a sampling. The second one is the margin of error. So what is the likely percentage of error that this could have, since this is not an actual count, this is an estimate. If you open the 2010 data, this is the decennial census data, meaning it's a total count of all the people within that area. You don't have a margin of error anymore, you just have a total, right? So those are the 2 tables that you just downloaded. So I will provide you with a list of demographic data that I want you to add to your census tracts, and also a list of other data sets that I want you to add to your project database. I want you to start thinking about whether you want to do your final project on something, a topic that is interesting to you, or would you prefer that we kind of assign a specific project. So an example of a project that I would assign is perhaps create some kind of process where you would identify areas of Philadelphia that is in most need of public services. So perhaps maybe like a area that is in most need of parks based on a certain criteria. So perhaps that could be age group within each census tract. It could be the availability of vacant parcels within each census tract, proximity to existing parks. So that's the type of project that I would assign, is find the most optimal location for a city park or something like that. So when we see each other again, I want you to come to class ready to conduct some geoprocessing exercises. So that means that you would have had to have watched this video, paid attention to it. And also I want you to have a geodatabase for your project created with layers added to your demographic shapefiles and other base map layers added. I will provide you with a list of layers that I want to make sure that you have. I will also provide you with the data site, the data sources page. In the meantime, enjoy your break. I sent this video to you late, but I think you have plenty of time to put this project database together. And again, be ready to do some geoprocessing exercises next class. If you have any questions, please feel free to reach out to me. Have a great spring break, and I look forward to seeing you all again very soon. Thank you. Bye-bye.